Hi, this is Chantel, and I'm talking about the quiz 2 from College Algebra at CCV in Winooski this summer 2019. So the first problem on this quiz, and this quiz was about exponents and factoring. This first one is an exponent problem, and they ask us to simplify and write with positive exponents. So we need to remember the rule that a to the n times a to the m equals a to the n plus m. So that means these both have the same base. So that means we can use this rule because they both have the same base. So that means that this exponent and the other exponent get added together, just like in my rule down below. So we have 2 to the 1/2 plus negative 5/3. So really this is just a fraction problem, nothing else. As long as you understand the rule, the rest of it you have to deal with the fraction. So I'm going to go over here, I'm going to say 1/2 minus 5/3, because that's plus a negative 5/3. So we have two different denominators here, 2 and a 3, and that means we need to find the least common multiple of 2 and 3, and that is 6. So we need to make a 6 on both sides. So I'm going to multiply this one by 3/3 and this one by 2/2. And I get 3/6 minus 10/6, and that is negative 7/6. Okay, so that's the exponent. So the answer is 2 to the negative 7/6. And if you don't remember how to do exponent rules, there's lots of places to look exponent rules up online, and Khan Academy also has some great videos on that. Okay, number 2 also says simplify and write with positive exponents. So this is just another exponent rule problem. So this one is going to use the rule a to the n raised to the m power. And if you think about it, really this just means we're taking a to the n m times, and I'll give you an example of this in just a second, but the rule just says a to the n times m. And this is not something you need to memorize. Just use an example for yourself. Say, all right, well, I've got 2 to the 3 to the second power. That just means 2 to the 3 times 2 to the 3. Well, how many do I have? If you really need to break it out, say, well, 2 times 2 times 2 is this first one. And then the second one is also 2 times 2 times 2. I've got 6 2's. So that is 2 to the 6th. Okay, so we're going to use that same rule applied here. So what that means is I need to take the negative 1/2 and multiply it times the 3 and times the 2. So I get a to the 3 times negative 1/2. And then I've got that times b to the 2 times negative 1/2. Okay, so this again is just a fraction problem. So I get a to the negative 3/2 and b to the negative 2/2, which is just negative 1. Okay, so this, I'll just say, equals negative 1. All right, so the negatives just mean, the other rule is a to the negative n means means 1 over a to the n. 1 over a to the n. Okay, so you just take away the negative and put it on the bottom when the negative is in the exponent. So it's just telling us that we have 1 over, both of these are negative. So 1 over a to the 3/2 and b to the 1. The next problem asks us to simplify the expression, and it says in parentheses, combine like terms. Combine like terms. So this is just an addition problem, and I saw some problems with that. People used multiplication for some reason. Maybe you just didn't see the plus sign. But you just want to go through and find like terms. So I've got the x squared terms are here, and I've got the x to the 1 terms here, and you've got the constant terms here. Okay, so we're going to add together the green ones, 5x squared and 4x squared is 9x squared. And then the blue ones, 3x minus 2x, is just 1x, which is just x. And then the 3 minus the 1 is plus 2. And that's it. Okay, this next problem is looking at basically just a distribution problem. And so we're just distributing, we're multiplying, which means to distribute 2a squared across the trinomial. So the first thing we're going to do is we're going to take the 2a squared and we're going to multiply it by this first one here. So 2a squared times 3a squared, so you're going to multiply the 2 and the 3 to get 6. And you're going to multiply the a squared times the a squared, and that's the exponent rules, to get a to the 4th. And the next thing you're going to do is you're going to multiply the 2a squared times the a, and you're going to get 2a squared times a is going to give you 2, because there's no other coefficient here to multiply by. And the a squared times the a, again the exponent rules, gives you a cubed. So you're going to add together the exponents when you multiply the bases. And then the last one, 2a squared times 3, is going to give us 2 and 3 multiplied to give you 6. There's no a's in that one, so it's just a squared. And we've written it in the correct form, which is in decreasing power of a. And that's your final answer. The next problem asks us to just perform the operation, and we have an x minus 10 with the quantity squared. And I just wanted to remind everybody that this uses the kind of shortcut, I guess you'd call it, of a minus b squared is a squared minus 2ab plus b squared. And this just comes from the fact that we've got a minus b times a minus b because it's squared. So if you just used FOIL, you would get the exact same answer because you would say a times a, so that is the first one here, and that's a squared. And then you would do the outside one, which is this one, which gives you minus ab. And then you would do the inside one here, and that would also be minus ab. And then you would do the last one, which is here, and you got minus b times minus b, which gives you plus b squared. All right, so basically you just want to combine like terms here. So these two terms come together and they add because they're both the same sign, and there's two of them, so they become 2ab, and it's a negative. So we've got a squared minus 2ab plus b squared. And as you can see, that's the same as the shortcut or rule that we were given in one of the sections in the review. All right, so let's look at then what this would be. This is a, and this is b. Okay, so we're going to square the first one. We get x squared. We're going to say minus 2 times a times b, but I'm going to do b times a because we usually put the number first. 10 times x. And then plus, because we multiply negative 10 times negative 10, or 10 squared. Okay, so we get x squared minus 20x plus 100. So either way you do it, you get the same answer. You can also FOIL this if you want, and just break it out to x minus 10 times x minus 10, and you should still get the same answer. On this one, they ask us to perform just the given operation, and you have a multiplication of two binomials. And if you look at this, you can see that the terms are the same, first and last, except we have a plus and a minus. So this follows the rule of a plus b. And this is something that I really recommend people just try to remember or memorize. I don't recommend that very often, but this is one that's pretty important to memorize, because you use it so often in so many different situations. So if we just decided to FOIL this or distribute it, we would say first is the a times the a is a squared. And then we would get the outside here, and we would say minus ab. And then we would do the inside, which is plus ab. And then we would do the last one, and we get minus b squared. So as you can see here, the minus ab and the plus ab are going to subtract out. And that will happen every single time. As long as you have the same two terms and one is plus and one is minus, they will always subtract out. So you end up with a squared minus b squared. Okay, so this is a and this is b. So you have a minus b and you have a plus b. So that means we're going to have the first one, 3n squared minus 21mn plus 21mn, which you don't need to do because we have this right here. So we're going to say minus b squared, which is 7m squared. Okay, so we get 9n squared, because you want to square the whole thing, so the square applies to both terms. And again, applies to both terms. We're going to say minus 7 squared is 49, m squared is just m squared, and that's your final answer. This next one asks us to factor by grouping to completely factor the following. So completely factor means even if you think you're done, look at it and see if anything else factors. When we're asked to factor by grouping, almost always they've grouped it nicely for us. So just look at the first two and see if anything factors. Well, I see that an x squared can come out of both of those terms, and I end up with 3x. So when you multiply these back together again, you should get 3x cubed, and you do. All right, so now we'll look at the next term in the expression and see what factors out of the 5x squared. Well, we're left with, if we factor out an x squared, we get a 5. Okay. On the next one, we want to factor out a minus. Okay, so a minus 1 basically comes out of this. And also we end up with, it looks like 16 comes out of both of those. And the big clue is look at what you factored out here and see if you can get that out of each of them, because it probably is going to work out that way if they've specifically asked you to factor by grouping. And if we take 16 out of 48x, or negative 16 out of 48x, what we're left with is 3x, just like we were over on the left. And if we take negative 16 out of 80, we're left with 5. And look at that. We have the exact same expression here. So now if we take 3x plus 5 out of both of those terms, so we're going to take this out of the first set of terms here, okay? And what we're left with is an x squared, okay? So what we're left with is x squared on the first one. If we take a 3x plus 5 out of this second set of this expression, we're left with a minus 16. Minus 16. Okay? So remember I said to completely factor. So we've got 3x plus 5. It doesn't factor any further. But I do see that this is the difference of two squares. And we just looked at the difference of two squares before in the other direction. So a squared minus b squared is going to be a plus b times a minus b. Okay, so this is a and this is b. So we want to say, well, it's going to become x plus 4 and x minus 4. And if you're not sure about it, just redistribute everything and see that you get x squared minus 16, because the plus 4x minus 4x are going to subtract out. So this here is your final answer. Okay, this next one is just asking us to factor, not using any methods besides just plain old factoring. The first thing I look at is each term to see if there's anything that I can factor out, a greatest common factor. The first thing I would look at is 5 or a, and 5 or an a does not go into all of those things. It has to go into all three. So there's no greatest common factor. So I'm just going to go ahead and see what I can do with this. So 5 only goes as 5 and 1, and so it's going to be 5a and a. And 30 is, well, first thing you've got to do is you've got to think about, this is one of those ones you kind of have to take it one step at a time. You've got to think about the minus and the minus. So what am I going to put in the signs here to multiply to be a negative and add to be a negative? So the only way to multiply and get a negative is to have a plus and a minus. So I'm either going to have plus and minus like this, or I'm going to have 5a minus and a plus. I'm going to get rid of those red lines because that's a little confusing. Okay? So those are our two choices. And we just have to figure out what's going to go in there. So 30, I immediately think about 30 as being either 1 times 30, 30 times 1, or I've got 3 times 10, or 10 times 3, and another one is 5 times 6. Okay? So if you try 30, that's going to be, I don't think you're going to get close to 19 in the middle. Oh, and by the way, because this is a negative, we are looking at the difference between, and because this is a positive and a negative in these factors here, we're looking at the difference to create a negative. So when we have a plus here, and we have, or a minus, and then we have the opposite sign here, then that means when we put them together, we're finding the difference. One's a plus and one's a minus. So what we're trying to do is we're trying to find a minus right here, a difference between two things that's negative. Okay, so I can try putting, how about a 5 here and a 6 here? So I'm going to get plus 5a minus 20a. And that is going to give me negative 15. Well, that was pretty close. So I think I'm going to erase that, and I'm going to try it the other way around. So I'm going to say 5a plus 6 and a minus 5. And I get, in this case, I get negative 25a plus 6a. Ooh, and that is going to give me negative 19a, which is exactly what I was looking for as my middle term. So this is the answer. So this is called guess and check for a reason. You just have to play with it and use a little bit of logic. It's like a big old logic puzzle. And that's your final answer. We're being asked to factor the following as the difference of two squares. So they've even told us what it is. And the difference of two squares is a squared minus b squared equals a plus b times a minus b. All right, so 4x squared, this whole business right here, is a squared. And this whole part right here is b squared. So you've got to figure out what the square root of that is. So that means that, let's figure it out right here. A is the square root of 4x squared. So that is 2x. And b is the square root of 25y squared. So that is 5y. Okay. So now let's rewrite this as 2x, the whole thing squared, minus 5y, the whole thing squared. And now we know what's what here. And we're going to factor it as a, 2x, plus 5y, which is b, times a minus 5y. Okay, and that's your final answer. The last question asks us to factor the polynomial completely. So again, when I have a polynomial and I'm factoring it, the first thing you should do is to look for the greatest common factor. So I see here that y to the fourth, y to the third, and 2y squared all have some y's in them. So I'm going to see what the highest exponent I can pull out of each one of these is, and I see that I can get y squared to come out of each one. So if I factor out a y squared from y to the fourth, I get y squared. And if I factor it out of y cubed, I'm left with y. And if I factor it out of negative 2y squared, I'm left with minus 2. All right, so now I have something, it's a trinomial, it's pretty simple, and you want to check to see if it's factorable. So I'm going to see if I can do something here with y plus and y minus or something like that. So I need something that's going to multiply to be a negative and add to be a positive. Multiply to be a negative and add to be a positive. So that is going to have to be a plus and a minus. So for something to multiply to be negative, you have to have a plus and a minus always. So what can I choose that's going to multiply to be 2, negative 2, and add to be 1? Well, I'm going to have 2 and 1, so 2 times 1. One of them has to be negative and the other positive. When we add them together, we want it to be positive. That means my bigger number needs to be the 2, and the smaller number needs to be the 1. So you can double check that and make sure you agree. All right, and that is your final answer because that does not factor any further. All right, thanks for watching.